Yes, students. Now we have already seen in the previous video that uniquely determined analytical function and the theorem we already seen. Now we'll try to write in a order what are the things we have discussed, that we are going to write in a proper order how you are going to solve the prove the theorem. Okay, now this is what we have discussed about that what are the things we need to take care to solve to prove the theorem. Okay, we'll write in order. Okay, now this is how we can write. Now to prove the theorem, we first establish the following result. The result is nothing but suppose f of z is analytic in a domain D, and let f of z is equal to 0 either on line segment L contained in one second. Yes yes contained in D on a or on a subdomain D contained in D, then f of z is nothing but equal to 0 on D. Okay, now this one will try to prove what we have discussed, the same thing. Let P be any point in D and such that let Z not belongs to L or Z not belongs to D. Let D is the distance from the polygonal arc to the boundary of D. Boundary of D, that is nothing but equal to distance from, I have taken as gamma, to D. In the case D is entire plane, we can take D is nothing but a positive, that is nothing but greater than 0. And choose the points Z1, Z2, Z3 and so on, Zn minus 1, Zn which is nothing coincide with P, such that mod Zk minus 1 is less than D, K is nothing but equal to, and so on. Now this is the diagram which we have taken. Now this is nothing but D, this is the capital D which we have taken, the capital D, and points Z0, Z1, Z2 and so on, Zn is coincided with the P, and this is the distance between the boundary and the line segment L. This is line segment L. Gamma be the distance between the 2 points. Okay, now and Zk minus is less than D, the K equal to 1 to this, and Nk is nothing but Nd, the distance neighborhood Zk minus 1. Now this is what we have diagram, that is Z0, Z1, Z2 and so on, Zn minus 1, Zn, that is nothing but P. We have taken a neighborhood N0 with the center Z0 and the point Z1 also included in this, and in the same manner N1 with the center Z1, the point Z2 is also included. In the same manner N2, the point Z2 as center and Z3 as a point which is included, like that and so on. We have taken Zn, the neighborhood, that is nothing but Nn, which is lying the point Zn minus 1, and there is a point Zn minus 2 will be there here, Zn minus 2, and Zn minus 1 is the center, and that this is nothing but a neighborhood which is nothing but contained in the D. Okay, now we use the following result which will be proved later. Now result which we have, that result will prove later in the coming chapters. Now the result is, if f of z is analytic in the neighborhood N, f of z is equal to 0 either on line segment or on a subdomain, this is which is contained in E, then f of z is equal to 0 on N. Now this is the result which we are going to prove in the coming chapters. Let us take, this is nothing but number 1 using 1. So f of z is analytic on N0, what we have taken the neighborhood N0, and f of z0 is nothing but equal to 0. So that implies f of z is analytic on N0 and is 0 on line segment or a domain, okay, or a subdomain, and contained in N0 by the hypothesis. So therefore f of z is equal to 0 in the N0. So similarly, because of since Z0 is a center and Z1 is nothing but point lying in the N0, I can say f of Z1 is also is nothing but equal to 0 as Z1 belongs to N0. Applying this one, the first one, the first equation 1, we can say that applying to the N1 we get that f of z is nothing but equal to 0 on N1, because Z1 is nothing but 0, so it is 0 means it is nothing but analytic, so f of z is equal to 0 on N1, therefore f of z2 is nothing but 0. F of z2 0 means it is nothing but analytic on N2, therefore f of z is also 0 on the N2, like that and so on. F of z equal to 0 on Nk minus 1 and f of Zn is also equal to 0. This proves the result what we are supposed to prove. Now we prove the theorem uniqueness like this. Now taking f of z, capital F of z is equal to f of z minus g of z. We have proved this star. Star means what we have chosen, the first equation, the first one. This is a star what we have proved. F of z is equal to 0. Now we are proving the uniqueness now. For uniqueness, we take capital F of z, which is nothing but difference of f of z minus g of z, and whereas z belongs to D. Since f of z and g of z are analytic in D, so that in hypothesis, so that we can say if these two are analytic, capital F of z is also analytic by the hypothesis. So f of z is also 0. This analytic means according to the previous result, we can say the f of z equal to 0. Either it may be on L or on D, which is subset of D1, which is subset of D. So therefore f of z is equal to 0. F of z equal to 0 for all z belongs to D. So therefore I can say, if I put 0 here, I can write that f of z is equal to g of z. Now this is nothing but called as a uniqueness. So f of z is equal to g of z for all z belongs to D. So only thing that you have to remember is, we are supposed to prove by taking the values, by taking the points, the nothing but if z naught is nothing but analytic, means z naught is nothing but belongs to the analytic, then I can say the f of z naught is nothing but equal to 0. F of z is nothing but equal to analytic according to the result which we have which we are going to prove in the later chapters. So this is how we can prove the uniquely determined analytic functions. Uniquely determined analytic functions by taking all the points. We have the theorem in this manner, so we can write it and we can prove it accordingly, such that which is very very important, that it is uniquely determined in a region where f of z is nothing but equal to 0 at each and every point of z, which is contained in D, where D is nothing but a open and connected set. So therefore we can say that f of z is identically 0. Okay, thank you.